So in my last video, I think I created a little bit of a lactate panic. Um, you don't have to fear lactate. I know that I said that lactate drives electrons into cells and pyruvate pulls them out, and that's why pyruvate is good. It helps us get some of the excess energy out of our cells. That doesn't necessarily mean that lactate is bad. It's really the ratio that's important. So that's what I want to talk about. I'm Brad Marshall, author of the blog fireinabottle.net. I've been doing this video series. I am promoting the concept of consuming two supplements together, L-carnitine and calcium lactate. If you get any supplements that you want from bulksupplements.com, you will save 12% if you use my discount code FIRE, F-I-R-E. And anyway, so in this video, I'm going to talk about why not to panic about lactate. So basically the question people are asking is something like, okay, so what I've been saying is that cells can take in pyruvate and they can convert it, they can offload excess electrons, excess energy onto the pyruvate and convert it to lactate, and they can export the lactate, and that obese people have higher circulating levels of lactate. And that's all true. But what happens is, and so lactate really is no different though than glucose. So pyruvate is different than glucose in that it's already gone through glycolysis and it's lost a couple of NADH. And that is really, NADH is really what's building up in the cells. When I say extra electrons, I really mean too much NADH that's not in the NAD plus form. And so, yeah, if sorry, just thinking about this whole thing. So what happens is in cells, the inside of the cell is mostly oxidized. So you've got in a healthy cell, and this was all found in cell culture. So it might be different in a living if you looked at something that's actually alive versus cells in culture. And these ratios are changing all the time, like depending on if you just ate or, so it's variable, but very generally speaking, a healthy cell has something like 400 NAD plus for every one NADH. And so that's one of the reasons why I think taking NAD plus supplements is a good idea. But since your cells are mostly in the NAD plus form, 400 times as much NAD plus as there is NADH, if the real win is if you can just get rid of a little bit of the NADH, because there's not that much of it to begin with, right? So you can really manipulate, and it really is about the ratio. It's not about the absolute amounts, it's about the ratio. And so what you want is a lot of NAD plus for every one NADH, because NADH, what it's doing is NADH is inhibiting a lot of the enzyme reactions that produce it. And that's how enzymes work. They get blocked by the things that they produce because, it's a way of saying, okay, well, we already have enough. There's already enough NADH, don't make more. And so that slows your metabolism down because your metabolism requires NAD plus and it requires low levels of NADH. And so we want to get rid of some of that NADH. But it's about the ratios. And like I say, the cells keep, especially in the cytoplasm, the NAD plus NADH pool is mostly oxidized. It's mostly in the NAD plus form. And that's, and NADH is the reduced form. There's a little clever thing called oil rig, which means oxidation is losing, reduction is gaining. And what they mean is electrons. So NADH is an electron carrier. NADH is the one that has the electrons. Therefore, it's the reduced form because reduction is gaining. And NAD plus has given up the electrons and therefore is the oxidized version. So the NADH pool is kept in a very oxidized state, and that is just the way that the enzymes work. That's how they want it, right? Conversely, in the bloodstream, we have a similar pool, lactate and pyruvate. So lactate and pyruvate can be swapped back and forth by enzymes, and they're just taking the two electrons from NADH and they're adding it to pyruvate to make lactate, or they're taking the electrons back off of lactate and making it back into pyruvate, and they're putting the 2 electrons back onto NADH. So, and this is a dynamic process that's happening all the time. Like all of the cells, all of the time, are rapidly importing pyruvate and lactate, and that enzyme is running, just swapping out NAD. You know, if the cell's pulling in a relatively high amount of pyruvate, it's going to be taking some of those NADH and it's going to be offloading the electrons onto that pyruvate. And when I say relatively high, a healthy person has about 30 times as much lactate in their blood as they have of pyruvate. And so here's the good news. If you're trying to manipulate your NADH to NAD plus ratio in your cells by consuming pyruvate, since we have only 1 pyruvate for every 30 lactate, it means to change that ratio doesn't take a whole lot of pyruvate, right? And so pyruvate is present in the bloodstream. It is, but it's in very small amounts. So, when you take the protocol we've been talking about is about 12 grams a day of pyruvate, which is quite a bit compared to what is in your blood. And so you can really change that ratio. And people have been asking, well, if we do that, if we eat a bunch of pyruvate, isn't that going to sort of build up the levels of lactate and lead to this issue later? Am I like am I just sort of kicking the can down the road? And my answer is you're not. And it's because all of these circulating systems are constantly rebalancing each other. And so adding the pyruvate, it's just shifting the redox balance towards a more oxidized state. And since it's basically just glucose that's given up. And what I was going to say about lactate is don't worry about the lactate, because the lactate from a redox sense, lactate is just glucose, because glucose comes in with those 2 extra pairs of electrons that get made into the NADH in glycolysis, and then the cell sticks and that makes pyruvate. To make the pyruvate, the glucose gives off 2 NADH. But then you take those 2 NADH and you stick them back onto the pyruvate, and that gives you 2 molecules of lactate, and that gets exported. But so the lactate is essentially exactly the same as glucose. There's a really good paper about this called Lactate, the Ugly Duckling of Energy Metabolism, where they talk about how lactate is used as fuel by a lot of tissues of the body. Actually prefer lactate as fuel. And so there's nothing, and someone on Twitter asked, maybe I shouldn't eat yogurt because yogurt has the bacteria are producing lactate, that lactic acid, that's what makes yogurt acidic. But you don't have to worry about lactate, right? You don't have to worry about lactate. You have to worry about redox balance. And so redox balance is just determined by the ratio of lactate to pyruvate. And since pyruvate is kept at such low levels in the bloodstream, it's a very good lever, because it doesn't take a ton of pyruvate to add to that, and it's it's in the denominator and it's a small number, so it's easy to make it a little bit bigger, and that has a really big effect on the ratio. I don't think so. So my answer to the question is consuming pyruvate just kind of kicking the can down the road, and we're going to make this problem where we're building all this lactate, and that's going to come back to bite us? My answer is no. I don't think so. I think lactate in the first place is essentially the same as eating glucose. And what I did say was this. Again, I said lactate pushes electrons into cells and pyruvate pulls them out. And I was talking specifically about researchers took cells and they incubated them in pure lactate. And so in that case, you've got 100 lactate and 0 pyruvate. Zero's in the denominator, so the ratio is infinity, right? You have infinity of lactate. And yes, if your bloodstream contains pure lactate, then yes, you will push electrons into your cells. And conversely, with those cells, they gave them pure pyruvate, so the ratio is literally 0. It's 0 on top, 0 lactate, 0 on top, 100 pyruvate. So the ratio is 0. And in the ratio of 0, sure, you can drive those cells to probably something that looks like oxidative stress, right? Because you're like taking away all of the NAD plus or NADH, I mean, in that case. And so, yes, so the statement was technically correct. Lactate does push electrons into cells, and pyruvate does pull electrons out of cells. But what I should have said is that it's the ratio that matters. And so taking the supplemental pyruvate is a pretty powerful lever because there's not that much pyruvate in your blood to begin with, and there's not that much NADH either for cells to offload because the NAD pool is maintained in such an oxidized state, right? 400 NAD plus for every 1 NADH. And so the absolute amount of that's still too much NAD. It doesn't sound like that would be too much NADH, but the way the system works, 400 to 1 is fine, but if you're at 300 to 1, that's too much NADH. It doesn't sound like a lot, but still, you just need to pull out a little bit of NADH to get from 300 to 1 back to 400 to 1. And so that's why I like the pyruvate so much, because it's just increasing, it's just making the system a little more oxidized at the end of the day. I mean, at the end of the day, the pyruvate still goes into the nucleus and, ultimately gives off 3 more NADH anyway, as it gets converted all the way down to carbon dioxide and water. So nothing changes that. It's providing it's providing some buffer space and some room to get everything running, to get your metabolism running, to remove, the NAD plus is stimulating sirtuins. It's activating sirtuins. And what they do is they remove the acetyl groups from your mitochondrial enzymes, and the acetyl groups are turning them all off. So like your complex 1 isn't working, your complex 3 isn't working, your NNT isn't working. And so that momentary surge of NAD plus is getting those acetyl groups off, getting everything to work. And then, and I notice, if I take 6 grams of pyruvate, I have an all day long increase in body temperature. And you're also what happens is when you take pyruvate is you're activating not only sirtuins, you're probably activating AMP kinase, because AMP kinase is also controlled by SIRT1, by the sirtuin. And so you activate the sirtuin, that activates AMP kinase. AMP kinase and SIRT1 together activate PGC1A, and that is the key thing in mitogenesis, which means building new mitochondria. And mitochondria are never better than the day you drive them off the lot. If you brand new mitochondria are presumably, hopefully, especially if you're going to have some NAD plus around, or you wouldn't have activated PGC1A in the first place. So you're building these new mitochondria, and hopefully their mitochondrial enzymes are not acetylated yet, right? And so that it's a little unclear how long the taking the pyruvate shifts your redox balance, but I'm sure that a few hours is long enough to build some new mitochondria, and those mitochondria have a half-life of 1 to 2 weeks. And so you will get some long-term sustained benefits from even just a few hours of shifting that redox balance, right? And so to answer my question, eat yogurt, it's fine. Eat sauerkraut, it's sour because it has lactic acid in it, it's okay. Lactic acid is really just glucose. From a redox balance, which is what we care about, it's just glucose. It's no different. It's not bad. It's just the ratio that matters. Thanks for listening.